In part B of our practice free response question states one of the conditions for inference that was met is that the number who chose the economy statement and the number who did not choose the economy statement are both greater than 10. Explain why it is necessary to satisfy this condition. So notice you didn't actually have to state the actual numbers. So I know in part A, we calculated in order to use the calculator command that there were 388 successes. So those are the people that chose the economy statement. If I took the sample size of 1,048, there it is. If I took the sample size of 1,048 and subtracted 388, I could find the count of individuals that didn't choose the economy statement, but that's not what the question is asking. The question is asking why we did that. So the number that chose the economy statement, I sometimes call that the success count. And then the failure count, that would be the number who didn't choose the economy statement. They both have to be greater than 10. Why is that? Well, that justifies why the sampling distribution of the sample proportion who would choose the economy statement will have an approximately normal shape. So checking to see that the success count and the failure count both exceed 10, both being 10 or more, that's what we call the normality condition. But you should be a little bit more specific if one free response question is dedicated to just explaining why the normality condition matters. Be specific. So why does the normality condition matter? What is approximately normal? Well, it is the sampling distribution for that sample proportion that would choose the economy statement. That's what has to have the approximately normal shape. And that word approximately is important. This is an approximation to normality. So question, or part C, the last part of the question, is also about writing about a condition. So a suggestion was made to use a two-sample z interval for a difference between proportions to investigate whether the difference in proportions between adults in the US who would have chosen the environment statement and adults in the US who would have chosen the economy statement is statistically significant. So we're essentially saying, can we do a two-sample z interval to see if we can find evidence of a difference between those two population proportions? So we could do this as a confidence interval. If we did this as a test, it would be a not equal to alternative. So it's a two-sided or a two-tailed test, but you're not being asked to do the test. You're not being asked to build a confidence interval. You're simply being asked, is the two-sample z interval for a difference between proportions, is that an appropriate procedure to investigate the difference using these data as they've been presented up here? Is this a good idea? Is this a procedure that is justified? So explain your answer, justify your answer. Your job is not to do any type of procedure. Your job is to explain whether we could or not. And the answer is no, we can't. So there are three conditions: the randomness, the independence, and the normality condition to check. So a two-sample z interval, or a two-proportion z interval, is what this would be, because we would be looking for a difference between two population proportions. So would require two independent random samples. The 10% rule then for independence would have to be met for each of those samples. And then we would have to check that the success and failure counts for both samples exceed 10 or more. So one of those conditions is going to be violated. And it's the very first condition, having two independent random samples. So notice, a two-sample z interval, or you could have said a two-proportion z interval, requires two independent random samples. In this situation, there is only one random sample. It says so in the very first sentence. There's only one random sample. So we don't have two independent random samples. So in other words, the percentage that would choose the economy statement versus the percentage that would choose the environment statement in this one random sample, well, they depend upon one another. If more people choose the economy statement, then you might potentially have fewer people choosing the environment statement, and so forth. So the bottom line here is you need, for a two-proportion procedure, you need two independent random samples, and you don't have that here because you only have one random sample.